Okay, everybody. So, what you'll be learning today?
Okay. Yeah.
Is that?
I was like,
Who is smiling? You can see him?
Yeah.
Alright. So, today will be stoichiometry, right?
That's really, hopefully it's true.
So, you guys want to keep talking or I should talk? I should, right? Okay. So, stoichiometry, what does the term means?
Calculation of quantities and reactants.
Calculation of
Chemical reactions.
chemical reaction. Is this correct? Anybody else? Any more idea? What it says? The calculation of quantities of reactants and products involved in a chemical reaction. So, the key point is chemical reaction. It has to be reaction. You have a reaction flask, reactant A, reactant B. They are reacting together, forming another product. Could be C, D, E, or only C, only one product. That means you can calculate quantities of reactant or product in a chemical reaction. The key point is chemical reaction. It has to be certain form of chemical reaction which can give you the quantities you need. So you need to know one quantity, then you can calculate the other one. It could be reactant to reactant, reactant to product. Anyone can calculate if you know one of them. That's called stoichiometry. Clear? Can you give me one example? Let's go on practical example. Any practical example you have in your life that you need to apply stoichiometry in there. Think about it. No laptop in the class, right? When I'm talking. So if you focus in the laptop, if you focus on the PowerPoint, you cannot focus on me, what I'm talking about. So I was asking, any example you need? Do you need to calculate any form of acidity, basicity, certain food, certain water, or any form of product you have to check? You could do that. You want to swim in a lake, you want to know this lake is safe for you or not. Grab some water, bring in the lab. If you want to check the acidity, react with the base. If you want to know the basicity, the base percentage, the level of base, whether it's safe or not, you can react with the acid. So they titrate each other, that means they react with each other and get a new product. So as you saw that in a reaction, you can calculate the quantity of a reactant or product. That means if you want to know the acidity of the water from the lake, then you react with the other one, what you know, and then you will be able to calculate the one acidity that you want to know. Just practical application. Okay. The second point you need to know that you cannot calculate until you make a balanced chemical equation. You can write an equation, for instance, let's go to a very simple example. Ammonia made from nitrogen and hydrogen. So you're making ammonia in there. Making ammonia from nitrogen and hydrogen. You'll be able to know any one of them if you know one of them. If you know nitrogen, you can calculate hydrogen. Or you can calculate ammonia, how much ammonia you're producing. If you have, for instance, if you have 2 grams of nitrogen, you will be able to know how much hydrogen you need to react with. If you have a 2 gram of nitrogen, you'll be able to know how much nitrogen it can produce. So that means you know one, you'll be able to calculate any of them. Could be reactant to product or reactant to reactant. Any one you can calculate. The second thing is you need to know the coefficient. That use prefix coefficient, that means balanced chemical equation. Before you any sort of calculation, you balance it out first. So, is it balanced equation? Yes or no?
No.
No. So, how do you balance it? I have 2 nitrogen. I have 2 nitrogen. I have 1 nitrogen in the right side, but I started off 2 nitrogen, right? So you cannot write 2 in here, can you? No. So you have to use prefix. And one of the way you do that, maybe you have a long equation need to balance out. So in that case, what do? You write on the top. For instance, you have 1, 2 here, then write 2 on the top until you are sure that you need 2 nitrogen. So at the end, you put 2 as a prefix. So 2 will go here, then nitrogen is balanced out. How about hydrogen? If you put 2 in here, there will be 6 hydrogen. But I have here only 2. So if you put 3, there will be 6 hydrogen. Both sides is equal. Now you see they are fine. Now you can put as a prefix. So this is balanced chemical equation. Then you'll be able to calculate 2 gram will be reacting with how much hydrogen in terms of mole, in terms of gram. So gram or mole, either one you can calculate from if you know one of them. You'll be able to calculate amount of product in a mole, in a gram, either one, right? That's the stoichiometry. You'll be able to calculate from balanced chemical equation whatever you needed if you know one of them. So let's try to solve one. So as I said, 2 gram nitrogen is reacting in this reaction. The question is, first go with ammonia. How much ammonia will be producing in gram? Right? Then this is the formula. You have the gram of A, the one you starting off, that would be A. The one you need to calculate this, you can take it as a B. Right? So A to B. You have the gram you go to the mole first. Then mole, you go to the mole of other. So if you know the gram, you did last class, how to go from gram to mole. And then mole to mole of the one you're going to calculate. Multiplying, you see, multiplying molar ratio. Mole of B over mole of A. The one you're going to calculate, that's going to be in the top. And this is going to be the one you have, what you started off. Nitrogen in here. Then you multiply with a gram over mole. You did this part in the last class. If you have the mole of any one, you multiply the molar mass of the one. Then you can get gram of that substance. So let's work together, okay? So I have 2 gram of nitrogen. Step 1, I need to go gram to mole of A. This is the mole of A that is starting off. So nitrogen molar mass. Molar mass of nitrogen, look at the periodic table. As I said, decimal, 1 digit of a decimal is 5. So it is 14.0. So which is 28.0. So 28.0 nitrogen So you're going to calculate mole, not to the gram. So 1 mole of nitrogen will be 28.1 decimal digit gram of nitrogen. Why did I do 28? Why did I put 28 instead of 14?
Because there's two.
What even 2?
There's two nitrogens. Diatomic.
They are diatomic, right? So 4 atoms are diatomic. Who are they? Hydrogen, oxygen, nitrogen and
Halogens.
halogens. Wonderful. So nitrogen is one of them. They are diatomic. So then step 2, multiplying coefficient of B over A. Which one is A? Nitrogen. So how many mole of nitrogen you have in the reaction? Exactly, 1 mole of nitrogen, and on the top will be B. B is the one is going to calculate 2, which is ammonia. So 3 mole of this 2 mole. So 2 mole of ammonia that producing here in this equation. The last step, you got mole of B. Last step, you're multiplying by molar mass. Gram of B over mole of B. So 1 mole of B is ammonia here. 1 mole of B, and ammonia is, look at the nitrogen, 14 times 3. So for ammonia, molar mass is 14 times 3 plus 1 times 3, 17.0 gram. So 17.0 gram. Always put 1 digit after the decimal. 17.0 gram of ammonia you're producing. You can use a cross dot in the middle. So now gram cancel out, nitrogen cancel out, ammonia cancel out.
34.
You have the gram of ammonia, what you need to calculate, as you see in the question saying that. How many grams of,
Oh, I see.
okay, so question is how many grams of ammonia you producing, right? So grams of ammonia is here. In exam, you do not need to cancel out exactly it is, right? This is always question, do we need to cancel out? You don't have to. Second question always comes, sometimes students confused. Are you cancelling 2 and 28? You do not. You do not cancelling number, just cancelling the unit of nitrogen, mole of ammonia and mole of ammonia. Then you get 2 times, on the top you have 2 times 2 times 17. And you have in here 28.0. So 17 times 4 . 2.428 gram of ammonia. Any question, please? Okay. Then can you solve the next one? If you have no question, can you solve this one? Look at that one you have here. You have propane, which is gas, you compressing into the liquid to use in a cylinder, right? Then burning. So burning means reacting with oxygen, forming carbon dioxide and water. Is this reaction balanced out or not?
Yes.
Yes, it is. So whenever you see the coefficient, you just keep quiet. It is balanced, right? And then solve it. How many grams of carbon dioxide? What do you have? You have propane gas. Propane is given in a gram, you calculating carbon dioxide. Which one is A in here from the formula?
Propane.
Propane is A, carbon dioxide is a B. Instead of carbon dioxide, it might be asking of oxygen. How much oxygen is reacting in this reaction with a 20 gram of propane? It's going to be the same process. Reactant to reactant, reactant to product. So in here, reactant to product, propane to carbon dioxide. So instead of propane, gram to mole of propane, then multiply the ratio of propane, and on the top would be carbon dioxide. And mole of carbon dioxide, gram of carbon dioxide on the top. Then you get how much carbon dioxide producing in this reaction.
Oh, go ahead.
Shoot first.
I got it.
Wonderful, guys.
Trying to get that point. Trying to get that 1 point. Over here? Right here?
You might write up here.
Am I erasing here?
Yes, sir.
Okay.
So the first step, you calculate the mass, molar mass of propane.
Yeah. I'll just say it's in. Yeah. 1.
So, Josh,
Yes.
when you calculate for molar mass or formula mass, you don't have to keep writing separately. Look at the screen. Look at the screen. You just make it shortcut.
Oh, just do that. Okay.
That will save you time.
All right. Ooh, I'm gonna run out.
Anybody else having any question? I can help you out. There's a final answer you got?
Yeah.
Look at something in here. When you write 1 mole of propane, you write this gram of propane equal to 1 mole of propane. So this should be in gram. You better write propane just.
Oh, okay.
But 1 mole of propane equal to, and then this is gram of propane.
Okay.
Then put in G. So do I need to, whenever in terms of exam, make sure you need to write out in details. Gram, you're converting, writing the proper unit. But yeah, you can go to, you can go. So if you do not write in the free response questions, it's going to be points off from the free open-ended questions. But in multiple choice, it's fine. You just need to calculate as you know. Make quickly, you get to calculate, done, and then get the answer, and then pick your answer. But free-ended questions, you need to show in detail. You need to cut out exactly, but at least show the units. That how you got gram in there as the answer. Yes, sir.
So if I got like 60.0, is that okay, since it's within 0.1?
If it is close, that should be okay.
Okay.
But as I see here, it should not be 60 because it's 58.8. That should not be 60.
Yeah, on mine it was 60.01, so is that okay if it's just barely off? Or do you need it?
It is not barely off, it is pretty much off. But 50.8,
It's 59.8.
Second.
That's a 9.
59.8?
Yeah.
Oh yeah, I think that's the right answer. So that was 59.8. Yes. Now you are barely off.
I had 9.
Gosh. You are now barely off, 59.8 instead of 60, that should be fine.
Okay.
Yes. As long as you maintain proper CPR.
Okay.
So how many CPR you need to maintain here? 3. So that's yours. If you write 60, that would be 60.0. Right. That's the question. Okay. Wonderful.
10 points on this.
Okay. This one. Can you solve this one quickly?
We just did this one.
Guys, you gotta read the questions carefully, okay? Read the questions carefully whenever you answer it. This is not the same one as we did before. And you had that PowerPoint posted, right? If you confused with that, that means you did not look at the PowerPoint.
That's how I got it.
And how did you make your pre-assessment? Pre-assessment, you make, look at the PowerPoint, open the book, and then you know which concept, which sections we are going to be covering in the class. Then that's how you prepare your pre-assessment. Make sense? Okay.
Yes, makes sense. 10 more points on the quiz.
I'll second it for 20.
What'd you get? 72 points. Mine 7.
So then, I know that I can.
No,
That's
don't
all.
ever change it. Fine, just about the third
I
one.
think they're the same. 72? Dude, this was nice.
There you go.
Good.
Very quick question,
I
right?
did it. I did it.
So,
CO2.
I did it right.
It's supposed to
Oxygen instead of CO2, right? You see something? So reactant to product, reactant to reactant. So that should be propane, right?
Yeah.
Not carbon dioxide.
Isn't it 4 or 3 moles of O2?
So if you correct it out, then C3,
It's the same thing, she just miswrote CO2.
what's that?
It's the same, she just miswrote CO2 instead of propane.
But the molar mass is same
Yeah.
for
Basically.
14.0, yes. So 1 to 5? Yes.
Yeah.
Right number, bro.
So
Name.
coefficient are same?
Yes.
Yes, 1 to 5, exactly. So this is the right answer. Thank you. Okay, what's the next term? Limiting reagent. What is it? Sorry, I keep asking the questions, right? I promise I will keep doing that.
It's whenever you have a small amount that the reaction can only go so far until that small amount's used up, and then it stops.
Right.
That's the.
That's the actually basic concept, yes. Any other idea?
What runs out first?
What, yeah, if you tell it very shortly, what you say, she just make it very short. Whatever run out first in the chemical reaction, that's called limiting reagent. So how do we know that? Which one ran first? How do you know that which one running out first? I have a chemical reaction, right? How do I calculate that one finish out first, the one will be left over something? Any answer for that? Let me ask you one more question. Anurag, terrifying? Okay, I'll do that. Okay, give me one practical example of limiting reagent.
Cheeseburgers.
That's true.
You got 3 patties, 4 cheeses, and 2 pieces of beef.
Yes. Okay, let me give you one example from the class. Okay?
Propane.
Live example from the class, right? We all decided to gonna have a race.
Yes.
Yes?
Yes.
And then we all went outside in the street or the field, and then we started a race. We decided that we all gonna be in the same pace. We are not gonna leave out anybody behind. What happened? Started the race, and I'm the last one because I'm fat man. And I'm not too fat, but among the class, of course. So I'm the last. Everybody looking at me. He said, "Hey, we planned that we're gonna be in the same pace. You can't run faster. Stop. Look at Dr. Haque. This guy is not running enough, right? So follow him." So question is, who is controlling the race of this class?
You are.
Fat guy.
I'm the one fat guy. Unfortunately, right? Okay, I accept. I take it, okay. True is true, right? Even though it's bitter. Okay. Exactly same concept. So, as I said that, race stopped because I cannot run anymore. Right? In chemical reaction, you have, if you look at the earlier one, you had 2 reagents, right? Propane and oxygen. When reacting with them, one will run out earlier. So the one will run out earlier, then that one will decide how much product you're producing. So that's the concept. So first point is limiting reactant, smallest stoichiometric amount. Second concept is one limiting reactant, once it runs out, reaction will stop, right? And then theoretical yield can be made from limiting. As I said, Dr. Haque is going to be deciding the rest of the class. So the one is limiting, that will determine how much product you are producing. Let's go on another example. Someone said that, right? Bread and cheese example.
Yeah.
Okay, what is it? You're making 2 bread with 1 cheese, right? You're hungry. You're hungry middle of the night. You jump into the classroom, jump into the kitchen, not classroom, right? Right. And then you started to making your sandwich from bread and cheese. Then 2 bread will need 1 cheese, right? So you saw that you got about 6 slices of bread, 4 slices of cheese. Look at something carefully. Seems like you got a lot more bread than cheese. You might think, hey, I got less cheese, I got a lot of bread. Actually not. Because when you started making the sandwich, then you saw that you are able to make only 3 sandwiches, and the more number was bread which ran out earlier. And then, so the left will be cheese. That means in a chemical reaction, you have to see what is the stoichiometric ratio they are reacting to each other. Then you decide which one is limiting after calculating their mole in the reaction. So which one is the limiting in here? Bread. How do you know? You made your product. Look at it carefully, every step. You need that when you calculate that. You have two reactants. You made a sandwich. You have to make your product first from your both reactants. Then you looked at which one you are finished out. You saw the bread. So bread is the one will be telling you how many sandwiches you can make. So if you have a 2 reactant, you calculate your product, and which product is the final actual product, that will be you looking at which one is the limiting. Let's go simple and basic example. That will be more clear. So I'm going to go the same example we did today. Nitrogen plus hydrogen forming ammonia. So 2 molecule ammonia is forming from 3 molecule of or 3 mole of hydrogen. So now I have, for instance, I'm starting off 2 gram of nitrogen and